Hey, how's it going everybody? And welcome back to Michael Workspace. I am Michael, and in today's lesson, we'll be going over a question that you may encounter in one of your upcoming tech interviews. It's a data structure and algorithm questionnaire, and let's just go ahead and jump right into the problem statement. The following problem gives a good insight into working with arrays, or more specifically, with the Python language, a list. Given an array of integers, reorder its entries so that the even entries appear first. This would be easy if you were to use O of n space, where n is the length of the array. However, you are required to solve it without allocating additional memory. The ordering of the array of integers does not matter, so long as the even integers comes before the odds. So an example of an inputs would be an array that looks like this: 5, 2, 6, 9, 4, 10, 0, and 1. And the outputs would be something that looks like this, where the even integers appear before the odds. So as you can see here, the highlighted numbers are all evens, and then afterwards it is odds. And this is a where it says the order of the array of integers does not matter so long as the even integer comes before the odds. So preserving the ordering of the numbers inside the array is not important in this particular questions. So let's go through. Maybe I'll give you a couple solutions here. One thing off the bat of my top of my head is a brute force solution or naive approach, which is basically just loop through, create a couple more arrays holding evens integers and then odds integers, and then do a single loop, and then check whether it is even or odds, and then append it to those particular arrays, and then at the end just return the combination of both arrays as one single output. That would have a complexity of a time complexity of O of n linear, but it also has a space complexity of O of n, where n is the size of the input array. And that might not be the best approach, but I'll quickly code it up for you, and then I'll show you a better approach to this. Okay, so let's begin with, since we're going to be working with lists here, I'll be adding some typing to this. So okay, so let's go with a brute force approach here. So I'll just call this evens before odds and brute force. And it's gonna take a array which we just call A, and is of type a list that's containing ints, and it's gonna return a list that contain ints. All right, so first thing here, let's go ahead and just quickly give write down what this time complexity and space complexity is gonna give us. Should give us a O of n linear time, and then also a space complexity of O of n as well for space. So let's go ahead and like I said, we'll probably just go create a couple arrays here. One's called evens and the other one's called odds. And then we'll just go ahead and loop through this array here. So I'll call for num in array if num mod 2 is equal to 0. So mod 2 is a modular. It's gonna give us the remaining after the divisor. So if the remaining of the number mod 2 is 0, it's going to mean that it is an even number. If there's a remaining left over, then it will be an odd number. So the remaining would probably just be 1. And then we'll go ahead and append, if that's the case, we'll go ahead and append num to the even array. Else, we'll append that number to the odd array. And at the end, we'll just go ahead and return evens plus odds. All right, so that will give us that. Let's go ahead and try it out an example here. So we'll go ahead and do print evens before odds brute force, and then we'll just go ahead and then throw in a quick array here of, let's do a simple one, 1 2 3 4 5 6 7 8, and then if we were to run this, oh, I am missing another closing parenthesis here. As you can see here, we have a return array that gives us the even number first and then the odd number last. Okay, so this is a working solution. However, it's not the correct solution for this particular use case, because the problem statement is clearly is saying that you are required to solve it without allocating additional memory. Okay, so let's go ahead and figure out how we can do that. Let's start out by creating another function. I'll just call it evens before odds and optimal. Again, it's gonna take in a input array. But this time it's not going to return a list for us, because we're going to be doing this we're solving this in place. So you're not going to be creating a additional array to contain the outputs. It's going to take what we have as input and then does like integer swapping based on the algorithm that we're going to code out in just a bit here. So it's going to utilize constant space, and that's going to be more efficient. Obviously, in this use case, we're working with a really small example for an array. However, in production, you may have a huge array that's tens of thousands of length long. So that does come into play when you're dealing with memory usage. So let's go ahead and code this up here. And then after I code this up, to give you guys, to really wrap your head around this, I'll go through I'll step through the code, and we can actually see it visually happening, and then you understand it more. You understand it better how we are approaching this new algorithm using integer swapping. Okay, so the time complexity for this will be a linear O of n, again linear, but then we have improved on it for the space complexity to be O of 1 constant. All right, and what we're going to be doing is creating two pointers for like the next even numbers and for the next odd numbers. Like we'll be keeping track of the indices of those two location in the array, and we'll do a comparison between those two values. And if it is even, we'll go ahead and keep it in place. If it's odd, then we'll swap the two to keep track of the two indices, and we'll move either up or down depending on whether it's even or odds. And I'll show you here once we code it up. So let's go ahead and just create a couple variables here. Next even, and we'll give it a starting indices of 0, and then next odd, and we'll have it as the ending indices. So we'll just be the length of the array minus 1, and we'll do a loop here, a while loop, while next even is less than next odd. So basically, while the beginning is less than the length of the array for the next odd indices, we're gonna keep going through this loop. We'll do a check here. If a of next even mod 2 is equal to 0 for even, then all we're gonna do is just leave it in place, and we'll just go ahead and increase the indices of our pointer, or even pointer. Else, now there's a remainder, it's odds. We're gonna go ahead and swap the two indices, and then we're gonna decrement the odd indices. So let's go ahead and do the swapping here. So next even, next odd is we're gonna go ahead and swap it using this method here. All right, so then the next odd will go to even, and then the next even will go to where next odd was, and then after that we're going to decrement the pointer for next odd. All right, and that should be it. We're not going to be returning anything here because we're going to be doing this in place, this array in place, the input. But if you want to, we can, the way it works is that we'll do like an inputs here. We'll do like, this is the input array, for example, and we'll do something like 5, 2, 6, storing out random numbers. All right, so that will be our inputs, and then we can pass it through our function here, and then pass the inputs list through our function, and after that, that doesn't return anything, but then we can afterward reprint the input to see what it shows us, and we're going to be expecting to see that this input variable that contains this list, original list, is going to be reorganized in place with the even integer first and then the odds afterwards. So let's see if this works. And as you can see here, this is the top example that we had earlier, and this is the after example. So the one that we just created with the even before odds optimal after being the passing the inputs to this function. That was what returned. All right, so if you guys are still not understanding that completely here, I'll go ahead and show you a visualization of this code being stepped through. All right, and I'll explain more in detail there. All right, so here's the function that we just coded up for the optimal solutions. I left out the brute force functions just because I believe it's fairly straightforward to understand. However, the optimal solutions, to understand like how the element swapping at these even and odd indices, or these 2 pointers, I think it's be easier if we can visualize it. So I'm using this website called pythontutor.com. It's by developer Philip Gao. I'm sorry if I said your name incorrectly. And just so everybody know, I'm not sponsored by this website, but I do use it frequently. So yeah, definitely check it out when you guys want to see how you code, like the implementation and how it is visualized, and also you can get help from other developers if you ever get stuck. So let's go ahead and step through this code here, and on the right side it's gonna basically draw out our code in different like frames and like some grids. So it's kind of cool. All right, so the way it works here is that right now we have just defined our even before odds optimal functions, and now it's going to create it's going to draw out our input variable onto this this grid as well. It's kind of cool, and there it is. So now that we have that, the next part of our code is going to be us calling our function with the input array. And now that we're inside of our functions, and it's going to create these 2 variables storing our next or 2 indices for next even and next odd. And there they are. So that's how this website works. Okay, and now we're inside of our while loop. So while next even is less than next odd, which it is because next even is 0 and next odd is 7, then we're going to check to see if the element at next even mod 2 modulo 2 is even or not. If it is, then all we do is just increment the next even indices by 1, and otherwise if it's odd, then we're going to do a variable or a element swapping at those 2 indices. So the element at indices. Let's just go through this next example because it's gonna be odd. So here's where we see that the element at indices 0 is 5, and then the element at indices 7 is 1. What's gonna happen now is that these two elements is gonna swap places, and then all we're gonna do then is decrement the next odd indices by 1. So it's gonna go down to 6. And as you can see, there it is. They have swap places, and then this part of the code here is going to decrement the next odd variable, and then we go back up to the while loop. So that's how this loop works. So if it's even, just increment the next even indices by 1. If it's odd, we're going to swap the two element at those indices, and then decrement the next odd by 1. And it's going to go up to, it's going to continue on until next even is no longer less than next odd, at which point it's going to break out the while loop and then return well, it doesn't actually return anything because we're doing this in place, but we can go ahead and print out our inputs to see how it has changed after it's being passed through our function. Okay, so we're going to step through here. You're going to see on the right side stuff changing, and when we get to a place where it is even, we'll stop and do a little further analysis here. So right now everything so far has been odd. Has been even, and then when we get to the odd places, then we'll stop and do a further analysis. So far we've just been going up this checking all the element at the indices to see what is evens, and it has been even so far, and then all we're doing so far is just adding incrementing the next even pointer by 1. However, when we got to the indices at 3, when we check to see whether it's even or odds, it is odd, so we fall down to the else block, and then we'll go through this where it does the integer swapping, element swapping at those indices at 3 and 5. So 9 and 10. 9 and 10 is going to swap places, and then next odd is going to go down by 1. And there they go, swapping places. And then we check the last remaining indices where if it's even at odds, and it is even, so we increment next even pointer by 1, and then when we went up to the while loop here, it's going to break out because now 4 is not less than 4, so it's not true. It's going to break out of that while loop, and then the last thing we're going to do is print out our input variables, which is a list, and then we get our final output results here. And as you can see, it is organized with the even integers first and then the odds afterward. Alright, so let's wrap up today's lessons. If you guys like this sort of content where I talk about data structures and different algorithms that you can use to solve interview questions, let me know. And if I get a lot of good positive feedback, or you guys saying that you guys like videos such as this, then I'll go ahead and create some more. And also, if you guys like to help my channel grow, please give me a sub and a like, and that's all I ask. I'll see you guys in the next video. Have a good day.